Okay, so today I want to talk to you guys about naming. So I'm giving you 2 days to work on this. So the review book had 2 pages of something that I usually cover in 3 days. So we're going to simplify it a little bit because we're remote, but there's a couple things that I would like you to add. So if you have your reference table handy, you should have table P and table Q and table R out, but I just want to focus on the first row on table R. And if you can add this, I know there's not that much room, but I'd like you to add that to kind of this part right here. So they're not halides, but these are other functional groups, methyl and ethyl, that your review book will talk about. Okay, so this just means this table R is kind of what's going to take us through the rest of organic chemistry. These are things that can be substituted for hydrogens and carbons and so forth. And that's why organic chemistry is so diverse, because you can substitute different things in there and create new medicines or whatever. Okay, so what I did first was I drew a butane molecule. So again, but meaning 4 carbons, table P, all single bonds meaning an alkane, so this would be called butane. Now the review book sometimes shows butane like that, with all the bonds around it. I'm not going to draw the hydrogens out from now on. I find that confusing. It's the way it really is, but they can bend in space, but it kind of gets confusing when we're going to talk about naming. So I'm going to always just give you a straight chain, meaning it looks like that straight chain. Okay, so what happens in organic chemistry is some of the hydrogens can get substituted. So, for example, I'm just going to take a hydrogen off here, and I'm going to substitute it with one of these functional groups. So I'm going to start with the halides right up here first. So I'm going to substitute that hydrogen with a fluorine. So what I want to do is I just want to kind of dot it so you see that that's different. So this is no longer butane because I stuck a fluoro group there. So every time you have a substituent group, which is a fancy word, just meaning a hydrogen is being replaced, you must give it a number. So just like your house number or your apartment number is where you can be found, like I live at 45 Weston Way. People are driving on Weston Way, they know to find me at 45. You would number the carbon chain so that you can give the substituent a number. So I'm going to count left to right. 1, 2, 3, 4. So my fluorine group is on the first carbon. So the way I would name this is I would name it 1, and then looking back up here on table R, fluoro, because it's an F, and then the parent chain, which is butane in this case. Okay, so a couple other things. So what if I put another fluorine on the third carbon right here? So now I have 2, right? So it's a different structure. It needs a different name. I would give both of them a carbon number. So this would be called 1, 3, a fluorine on the first carbon and a fluorine on the third. And then because there's 2 of them, difluorobutane. All right, so let me give you another one. Let's go crazy here. Why not? Let's get rid of those 2. And let's put a bromine here and a chlorine here. Wow, we're going hard here. Okay, so now I name these in alphabetical order. Because I have more than one substituent group, I'm going to name them in alphabetical order. So looking at table R, right? Br, well, regardless, bromo comes before chloro, which comes before fluoro. So the way I would name this, I would say 1, the location of the bromine, bromo, and then chloro comes next, alphabetically. 2, location of chlorine, and then 1, 3 dash difluoro, and then the parent, which is butane. So alphabetically is root, so it's not the prefix. We don't count the prefix as alphabetical. All right, a couple of things. Let me just change this around here. Let me make it a little more easy here. Let's go back to the hydrogens here. And let me put something that the text talks about a lot. a methyl group. So a methyl group is just a carbon. So instead of a fluorine or a chlorine or a bromine, they put a carbon there. So a couple things about methyl. This is a methyl group. So the way they write that is they write it like CH3 like that, but that means the same exact thing. So they're both methyl groups. So this is both a methyl group. So same idea, I would give it a carbon number, which is 2 in this case, and this would be called 2-methyl butane. Okay, so I'm going to give you a name now, and then I'm going to take you through drawing the structure, and then I'm going to give you another name to practice. Actually, there's one other thing I want to point out that can get confusing with organic chemistry. Okay, now I said I count from left to right. Now sometimes, depending on where the substituent groups are, you might have to count right to left. So I'm just going to draw a pentane chain out there, parent chain we call it. And I'm going to put a bromine here and just say chlorine here. Okay, because the density of the substituent groups is towards the right side of the molecule, you always want to make sure you number the parent so that the substituent groups have the lowest carbon number. So in this case, I would not count left to right, I would count right to left. So I would go 1, 2, 3, 4, 5. So you always want the substituent groups to have the lowest carbon number. So you may want to try to name this on your own. Pause the video, see if you can name it. Okay, I'm going to name it for you. 1 bromo dash 2 chloro pentane. Okay, so now I'm going to give you a name. Whoops. And I'm going to guide you through it. I don't know why that doesn't erase. Okay, so I'm going to give you 1, 1 dibromo dash 4 chloro dash 2, 3, 3 dash triiodo hexane. Okay, so I'm going to give you some guidance before you try this on your own. So start with the parent chain, which is hexane. So have a sheet of paper handy. Draw out your hexane chain. Draw all the bonds around it. Don't put hydrogens in there. You don't have to. And then number it. I would number left to right because that's how we read. And then go ahead and plug everything in. So if you want to pause it and just try it on your own, that's a great idea. Okay, so I'm going to start with my 6 carbons, meaning hex from table P. Draw all my bonds around it. I'm going to number left to right. You could number right to left if you prefer, but that would be more confusing for me. On the first carbon, I have a bromine. Doesn't matter where I put the bromine on the first carbon. If I wanted to put on the bottom, that would be fine. I'm just going to fill in the hydrogens. On my 4th carbon, I have a chlorine. On my 2nd, I have an iodo, which is I. On my 3rd, I have another iodine, and then I have an iodine here, and then everything else would be hydrogen. And I'm just plugging this in because you don't have to have the hydrogens on there all the time. It's implied. Okay, let me give you one more. How about you guys go ahead and try on your own. Let's see, how about 1, 2, 3, trichloro, oops. And there's commas between numbers and dashes between numbers and letters, but it's not very strict. The commas really between the numbers are the most important thing. 3-fluoropentane. So go ahead and draw that. Start with the parent chain, which is pentane, and see if you can figure it out. Okay, so here we have a chloro, a chloro, a chloro, and a fluoro, and that's it. Okay, well, you have a couple days to work on your homework, 2 days, but there's one other thing I want to point out. So I'm going to just kind of show you alkenes and alkynes and how you would name them. Okay, I'm drawing my bonds. Remember, being careful that I have 4 bonds around each carbon atom. So notice I have a double bond here. So now it is an alkene. So this would be called 1, 2, 3, 4, 5, 6 hexene. Now because this chain is long enough so that the double bond could actually be on a couple of different carbons, right? I also would number this chain. So I would number it so that the double bond has the lowest carbon number. In this case, I could go left to right or right to left. I would still end up with the same number. So 1, 2, 3, 4, 5, 6. So because that double bond is between the 3rd and the 4th carbon, I'm going to name it the lowest number, which is 3. So this one would be called 3-hexene because the double bond is not between the 3rd and the 4th. So again, I have to give it a number to identify where that double bond is. So if I change this up, I hope I'm not going to erase too much. And say I put my double bond here. Now that would be called, because it's between the 2nd and the 3rd, that would be called 2-hexene. And let me just follow up because I haven't really talked about the methyls that much. If I put a methyl group here, that's a methyl group, I would name that first. So first you name the substituent groups, and then you name the parent chain. So I would name this 2-methyl 2-pentene. And then the same thing for an alkyne, sorry. Because that triple bond is on between the 1st and the 2nd carbon, this would be called 1-butene. So I'm going to give you another screencast tomorrow. And again, you have 2 days to work on your homework in the textbook. So submit it to me either today or tomorrow, and have a great day.